Okay, now we're looking at a no interaction table, and most of this is going to be very, very similar, with our degrees of freedom being the number of factor levels minus 1 for each factor, but our degrees of freedom for error is a little different. It's going to be our degrees of freedom total minus our df for factor 1 and our df for factor 2, and again, df total is the total number of measurements minus 1. Sum of squares is the same for our factors. The real difference here is going to be our sum of squares for errors, which is going to be our SS total minus SS factor 1 minus SS factor 2. Again, SS total is the sum of the squared deviation of each individual measurement from the grand mean. Mean squares, like I said, very similar to all of our other ANOVAs. It's just going to be the sum squares for each variation source over that variation source's degrees of freedom. F statistic this is where we start to deviate from the interaction. So if you remember from interaction, the F value there was ms of the factor over ms interaction. But here we don't have an interaction term, so our F for each factor is going to be the mean squares of that factor over the error. And that's why we want to rerun it, because now we have a different mean square for our error, so we have to rerun it to calculate a new and different F value. And then we can use that F statistic to calculate the p-value. Again, the same formula, f.dis.rt, and then our x value, our F value is going to be F of that factor. Our numerator degrees of freedom is going to be that factor's degrees of freedom, and then our denominator is going to be the degrees of freedom for our error term. And again, here is that table that summarizes it all super beautifully for you. That way you can see it. Go ahead and pause. This is a great reference for you. And now